Welcome. So this was the other portion of 8.3 that I told you guys about in the last video. It's complex fractions. So a complex fraction, if that doesn't sound familiar to you, is when you have a fraction within a fraction. And absolutely, they can look scary. And I have no doubt that's exactly what most people are going to think when they look at them. And there are different methods to solving it. So let's start with that. I'm basically going to teach one method. And that's because to me it makes by far the most sense and what I've found most students are more successful with. And that's by taking the approach that if you have a fraction within a fraction, your goal is to make the numerator a single fraction and then the denominator a single fraction. And then by doing that, you're doing division, and then we can flip it, second one upside down, change the multiplication, and that's kind of the approach to take. Now, the textbook absolutely shows a completely different method. So, if you go through this and my method feels super confusing to you, I have no problem if you want to try a different method. The whole point of this is math has lots of ways to solve things, and if you show your work and figure things out the correct way, that's fine. So I'm going to show it this way though. So let's look at one example here. So we've got 2 over x plus x over 4 all over x plus 1 over x. And like I said, that looks kind of terrible. I get it. So when I mentioned that we want to try to have a single fraction on top and a single fraction on bottom, well, our denominator already is a single fraction, so we're kind of halfway there. So I'm going to focus on the top of this fraction. And I need to make 2 over x plus x over 4. I need to add them together so it's a single fraction. And I would do that by common denominatoring. So when I have an x and a 4, well, the only way to make them have a common denominator is multiply them by each other. So I'm going to multiply by 4 over 4 and x over x. And then that would give me 8 over 4x plus x squared over 4x. And I can write my top of the fraction is going to be 8 plus x squared over 4x all over x plus 1 over x. And so I've got a single fraction divided by a single fraction. And honestly, if I write it slightly different, so if I write it as the top fraction divided by the bottom fraction, this should feel like just what we were doing in the last section. And you're doing division of two fractions, so you change it to multiplication, flip the upside down, and then you're going to factor or reduce anything you can along the way. So I have an x that I see can cancel or reduce out. And honestly, that's it, because x squared plus 8 doesn't factor. And there's nothing for 4 to cancel with, so we did what we could. That's all right. So my top is going to be x squared plus 8 times 1, so x squared plus 8. On the bottom is 4 times x plus 1, and you could write it like this, or you could multiply them out, your choice. And then this would be a reduced final answer. But the important thing is, it's a single fraction. So complex fractions aren't necessarily wrong. They're just frowned upon because they look super confusing and they can make it difficult for your brain to process. So we traditionally will simplify them out. Okay, here's one for you to try. I take that back. I'm sorry. It looks like I was going to work with you on this one before you try one on your own. So let's focus on this one then. I've got a single top and a single bottom. And so we're already kind of set up correct, which means there must be something more to this. So I'm going to write it as a single top fraction divided by single bottom fraction. And I'm going to try to finish this. So change it to multiplication, flip it upside down, and then from here you're always supposed to reduce if you can. And looking at this one, x squared minus 1 does factor, so it's possible something's going to reduce from there. And, oh, for sure, x minus 1 cancels with x minus 1. Oh, and even x plus 1 cancels with x plus 1. And honestly, almost everything canceled out except for this x on the bottom. So our reduced finished answer is 1 over x. And there definitely are domain restrictions. I don't want to throw too much at you once here. But this would be the simplified answer. Okay, now you've got one to try on your own. I was off by one slide. My bad. So why don't you pause it here, see what you can do. And here is the worked out solution if you were able to get it. So you put the top together by common denominator, and then you get 3 over 2x over x plus 4 over x minus 2. So I'm going to write the single top fraction times the bottom one flipped upside down. And then if there's anything that can cancel, I would. This one doesn't have anything that cancels. So then I would just basically write everything out. So the 3 and the x minus 2, the 2x and the x plus 4. If you wanted to multiply them out, you could. It's just kind of your preference. Okay, last example, we're going to do it together. So I thought it would be good to have kind of a word problem style question in here, just so that you can get used to seeing questions done differently. So it says a freight train averages 30 miles per hour traveling to its destination with full cars and 40 miles per hour on the return trip with empty cars. What is the train's average speed for the entire trip? And I know for a lot of people, word problems can feel 100% different than the questions you're just working on. But then the whole point of that is, like we were just working on complex fractions, this word problem is going to have complex fractions in it. So that's absolutely why they feel different, because complex fractions aren't necessarily a problem on their own. It's just basically a method to solving things. And you often will run into complex fractions in problems. So I've at least helped you start this one. So average speed for the entire trip. The word average right there is actually what helps us out. The average speed is going to be found by figuring out the total distance the train went divided by the total time the train took. Okay, now off on the left-hand side, I wrote down the 3 different ways that you can write the distance formula. So I don't even remember which science class usually you learn that first in, but distance is rate times time. And you can rearrange this formula 3 different, for time or rate. And so we'll use that information to help us solve this. So average speed, total distance. Well, the train went somewhere and then it came back. And I guess there's a couple different ways I could phrase this or put this, but I'll probably just say that the distance there is d. And then the distance back is d, because it's the same distance. So the total distance was d plus d, or 2d. And total time, well, time is going to be the distance divided by the rate. Well, what did it say? It says it averages 30 miles per hour to its destination. So the time it took going to its destination is going to be the distance divided by the rate. Well, the distance we already said was d. The rate we were told was 30. The return trip, the distance was d, and the rate was 40? Yes, 40. So here would be the two different times. So the total time traveled would be this time plus this time, there and back. So I would have d over 30 plus d over 40. And then this is absolutely where the complex fraction comes in, because I've got fractions within a fraction. So let me kind of solve this, simplify this. The top of my fraction is 2d. Now, this is, when I mentioned my method of solving, I usually like to have a single fraction on the top, single fraction on the bottom. Well, 2d isn't a fraction, but I could write it as 2d over 1. So then I'd have a single fraction on top. On the bottom, I need to add d over 30 and d over 40, and they need common denominators. So 30 and 40 both go into 120. So I need to multiply by 4 over 4 and 3 over 3. And that would give me 4d and 3d. So that would give me 7d over 120. So I've got 2d over 1. Instead of divided by 7d over 120, I'm going to multiply by 120 over 7d. And then I'll reduce if I can. And I could cancel or reduce these d's. But actually nothing else reduces or cancels. And I get 2 times 120 divided by 1 times 7 times 1. 240 divided by 7 is about, I guess I'll change this to squigglies, 34.3 miles per hour, because that's what the R, we were finding average speed. So the train averaged 34.3 miles per hour. Okay, there's complex fractions within a problem. Excellent job. Excellent job. Okay, I'll see you in 8-4.